Boy, this weather really stinks today. Got some limb wood going here for my buddy Jim Mead's tree that fell down in his front yard. I'll show you what it looks like out the back door. There's about 14 inches out on the yard. So we'll be pretty snug and warm in here in a minute. Get some steam up. This is the packing gland nut for the steam engine. We have increased the size of the piston rod to 1 inch from 15/16, and so this had to be bored with about 10 thousandths clearance left. And also there was no angle. This is about a, what was it, 30 degrees? 30 degree angle? 45 degree angle?
Yeah.
45 degree angle on there, like other packing nuts have. This was flat. I don't know why they did it that way. Maybe they, in the old days, they were using some other kind of packing that didn't have to be compressed that way. But so those are the modifications on that. And then also, this is the lower cylinder head, and this has got to be bored out to 1 inch plus 10 thousandths for the piston rod to fit through it. So that's the modifications we're working on here. Boring the hole out in the cylinder head. That's the 1 inch shaft plus 10 thousandths. A lot of the parts on the steam engine that we're overhauling here are just badly pitted on the wear surfaces. And these two slides are for the crosshead between the piston and the connecting rod. And the critical thing here is you have to keep this distance and this distance the same. So I'm gonna just take about 10 thousandths off this surface and take the same amount off the top surface, so everything will be parallel and the same distance. And I've got it set up for a very, very light feed, 5 thousandths per pass. Get it in here a little closer so you can see it. Going to feed it over to the corner stop. take a little coarser feed on this because this is not a wear surface. On this job I had to resort to some modern machinery because I haven't got an end mill holder that will work in my number 10 Brown and Sharp tapered old milling machine. So I'm doing it on this old Bridgeport, and I've brazed this up here where the fit on the counterweight was not good on the crankshaft. So this has to be milled, this opening has to be milled to 2" plus 10. And then it'll be a very tight fit on the crankshaft. As you can see, the casting work here is pretty crummy. I wanted to make mention of some incoming items here from a viewer named Terry Berggren. He has a welding and machine shop in Farwell, Nebraska. and he's also a YouTube creator, and his YouTube channel is The Iron Worker, and he sent me a little note with it, basically just saying that the shop that he works out of used to be a line shaft machine shop, and he found a few things in the corners and thought I might be able to use them. And one is this what they call a paper pulley. It's built up with thousands of layers of paper or whatever, some type of fibrous material laid together and then riveted onto a iron hub. And these were very long wearing, and you got a lot of traction off that surface, and they were used for a lot of things in the old days. And also a really nice little solid pulley, got some crown in it, as you can see. And this would be a great pulley for a governor shaft, especially in a situation where you want to slow it down a little bit, because it's just a little bit bigger than usually a Pickering governor pulley is, and it looks to me like 3/4 bore, so it would be just about right. Well, thanks very much, Terry. We'll put them to use. Got a phone call a while back from a fellow named Paul Hardy from Elma, Arkansas, and he said that he had something that he'd been hanging on to for a long time that was pretty historically significant to the machine shop world, and described it to me. I knew exactly what it was. And what it is a portable cylinder boring rig for steam engines, like locomotives. They bored the cylinders on the locomotive, took the pistons and crossheads apart, and bored them out with this line boring rig. And you can actually do it by hand with a crank, but I think the crank was used mostly to line the thing up and get everything right. And then there's a big gear drive on the end of it that would bore the cylinders out in one pass. It was like a boring head on a boring mill that was fed with a lead screw and a star wheel that hit a pin every time it came around and advanced it to the cylinder. And I've seen pictures of them in books, and there's one down on the East Broad Top Railroad in their storage facility there that I've seen before when I worked down there. And he said that he rescued this thing from the scrap and had it for years and years. In fact, he had a new box made for it, like the old box that everything fitted in. And he had moved it several times when he moved, and he decided that it needed to find a home where somebody would take care of it and knew what it was, so it wouldn't end up in the scrap again. So he wanted to send it to me, and he did. I'm going to open it up. I have not seen it yet. It's still screwed down with 1,000 screws. He did a fantastic job making this crate. And another thing I want to mention is, he checked with a lot of shippers, and they were very high priced on this. I don't know what this weighs. Probably, I would say 250 pounds or more, maybe 300 pounds. And finally found a good shipper with Fastenal. I don't know, Fastenal, I believe, is nationwide. They're a hardware supplier, but they will also ship things for you. And this thing took about a week. And as you can see, there is not a mark on it. I've shipped stuff by motor freight and had it, everybody has, and had it destroyed in the process. There's nothing but a footprint on top of it where somebody walked across the top of it. But the box is in perfect shape. We're going to open it up. And I told Paul that, I said, if this thing is what I think it is, we're going to bore a cylinder with it. So I would like to, if it is within the size range to do it, actually bore the Morris cylinder with this rig. So I'll get some screws out of the top, and then the last couple of screws I'll take out and you can see. Okay, so it's the next day. Maybe won't have so many interruptions today. I got all the screws out but one. This is the last one. Paul really didn't spare the screws on this thing. Took almost a whole battery to get them out. Somewhere. Oh, right in the corner. See this. Alright, I have to get the engine hoist to lift this out of here. So we'll be back. My thinking is if I can unload it a little bit, it'd be lighter and I can get it on a dolly. Move over here. Beautiful job on the box. There it is. This is later model than I thought. This is a little bit more of an advanced design. And look at this. Yankee Tools. Well, here's the instructions for right here. Made by York. This is the actual boring head. This is the feed works. This is to engage the feed and disengage. This is to run the feed in and out. This is the gearbox. It's a worm reduction. Input there, output there. It's a hand crank. See, that would go on either one of these. This would actually drive the cutting head. I had a chance to look this over a little closer, and what we have here is actually an automotive boring bar for doing engine blocks, and it's a hand cranker. And this is the feed, either automatic or you can run it up and down. It's an automatic feed, little gearbox here with 2 speeds. One for rough, one for finish. And this engages and disengages it. It's got a little feather key in there that is a clutch. And it's made by York in Philadelphia. And it bolts, this part here will bolt onto an adapter. There's 2 different size ranges here. This is the smaller one. And this bolts on top of the engine block and clamps by the head bolt studs. And then then it fits on here. And that, of course, holds it perfectly straight with the cylinder. And then you have a couple of boring heads here. This is a smaller one. And over here is the larger one. And it looks like it will bore up to about maybe 4.5 inches. Cars and trucks, things like that. The cutting tools fit in these slots here. You can put several of them in there and set them up one behind the other as far as the amount they stick out, so you could have a roughing cut in the front and a final cut coming behind it. All the accessories for it are here in this beautifully made box. Paul said that this was the original, I believe he said this was the original top to it, and it was in pretty bad shape, so he had this box made up with all the little compartments in it for everything. And you can see here's the wrench for the heads, boring heads. This, I believe, is a gear reduction that can be bolted to it, or you can put a fairly high-speed driving mechanism on here, like an air. They would have used in the old shops maybe an air, like an air drill, a large air motor or whatever. So you can spin it with that by hand, I guess. It plugs in here. There's a drive pin in here that's kind of worn, and there may even be a socket for it down in there. So you can stand there and crank it, or you can run it with some kind of power, but the heads screw on here, and it looks to be in very nice shape. It's been used a lot, but really taken care of, and I don't think it's going to be big enough to bore a steam engine cylinder, but my thought is to see how much work it would be to make a bigger boring head for it that would carry one single point tool to cut a 6-inch cylinder. I don't know if the bar would be rigid enough, but we could try it. I really appreciate it, Paul, for all the time and effort and expense to send it out here, and we'll take care of it and try to demonstrate it. And I really appreciate it. This is the crosshead for the steam engine, and this is a wear surface right here, and you can see it's somewhat pitted. Same on the other side. And this was originally machined with a shaper, so we're going to remachine it with a shaper. We'll probably take about 10 or 15 off of both sides, even them up. Okay, the crosshead's set up in the shaper to machine this surface right here, and you can see we got a little bit of a problem with clearance here against the front of the ram, and also the clapper box here comes pretty close. I could probably set this up on its side with an angle plate, but it'd be a lot more messing around, so I'm going to try it and see how it works this way. And just take a very light cut off of here. Bring it down till it just touches. And go about maybe 4 or 5 thousandths more, and we'll try it. fine feet, 5 thousandths per stroke, about 5 thousandths cut. Now to get this side, I had to grind a left-handed tool to reach back up in here. And this is actually not even a piece of high-speed steel. This is very old. It's just carbon steel cutting tool stock. And it doesn't take much because we're going so slow on this. And it's cast iron, which is fairly soft. So it doesn't take much in the way of cutting tool material. And the cool thing about this is it grinds real easy. So I ground this one up, and that'll fit down in that notch like that. And it's got a couple degrees of side rake, and I don't know if you can see it, 4 or 5 degrees of top rake, and I radius the nose pretty good because I didn't want a sharp corner back up in there. So we'll try it and see how it goes. I'll get this set up, and got a couple more minutes to go here to get some steam up, and then we'll cut it. Here we get up pretty close. I'm going to disengage the feed and just run it up by hand so it just hits the corner. That's about it right there. Okay, there's the finished product. I mic'd this up and it's within a couple thousandths on all four corners, which is plenty close enough. And this is the valve guide block. These two surfaces were done on the shaper. These two were done on the vertical milling machine because of the problem of getting the tool right up close to this. And this is the new valve rod that Tom made the other day, and we even found 3 of the 4 brass nuts, so we got to make 1 nut. This is a little bit of a mock-up so you can kind of get an idea of how it goes together here. This is the crosshead that we just machined, and the brass tapered plate that goes underneath it to take up the slack and the wear. These are the 2 slides that I machined. These are the bolts that Tom made, and of course the connecting rod's going to go here, and just kind of checking it for fit, and that's what it looks like. The cylinder will go up here, course, and I haven't got this end of the rod threaded, but the piston will go on the threads on this end of the rod. And I still have to take the main bearing caps off and cut the oil channels, and I'm gonna drill and tap these oil reservoirs here for 1/4-inch pipe, and screw some pipe nipples in there that will stick up about this high, and then pour this area full of Babbitt, and then put a grease, a screw on grease lubricator on the mains, because it's so much easier than messing around with waste in here, cotton, cloth, and you gotta keep putting oil in it. And with the grease, a couple times a day, you just give it a twist and you're done. So that's it. Well, that's about all for this video. I'll get it put together and put up for you. Next one will be coming from sunny Englewood, Florida, about the first of the year. So thank you all for watching. Thanks for all the great comments, and it's been a great summer and fall, and have a great Christmas. Well, catch you later.